Hi, my name is Carlos Llanos. I'm going to talk about the predictors of citation of systematic reviews in oral implantology, a cross-sectional bibliometric analysis. Finish. The systematic review, with or without meta-analysis, are one tool that combines multiple studies trying to answer the same research question and provide an evidence summary without requiring clinicals to read multiple individual clinical studies. In the current scenario of ever-increasing number of dental journals and research articles, clinicals are faced with the challenge of navigating through the information overload to identify reliable scientific evidence to answer their clinical question.
This brief video will demonstrate how to find systematic reviews and meta-analyses using the PubMed database. Enter your search terms in the PubMed search bar. When doing a search, it's important to remember that there are fewer systematic reviews and meta-analyses than there are individual studies, so it's a good idea to use relatively broad and general search terms. For this example, we'll be using diabetes and patient education. From the search results screen under Article Types, click on Customize. This is a list of the various article types in PubMed. Scroll down until you see Meta-analysis. Select the box next to it, then scroll down until you see Systematic Review. Select the box next to it and click Show. Now these filters will be displayed in the left-hand sidebar. To activate the filters, just click on them. I'm going to click on Systematic Review, and then Meta-analysis. You'll see that active filters are in blue with a check mark next to them, and at the top of your search results, you'll see a notice telling you that filters have been applied. You now have a result set that consists of systematic reviews and meta-analyses.
In dentistry. In dentistry, there are several reports in the last decade that point to this huge variation in the methodological quality of systematic reviews, including our earlier reports in periodontology and implantology dentistry. We cite an article to have an impact at a scientific level and so provide Kathleen at the time to searching there.
From a distance, the steps of a systematic review look pretty basic. To answer a question or a series of questions, you just gather all the information that exists, filter out the information that doesn't apply to your question, then combine it all together into a report about existing evidence and research gaps. But let's take a closer look. Systematic reviews follow a rigorous scientific process. It takes more than a few steps to comprehensively gather, combine, and evaluate existing evidence. First, make sure you're asking your questions in the right way. It's possible your questions are too broad. So many people have tried to answer your questions in so many ways that you'll never gather all of the evidence. Or maybe your questions are too narrow, and there's no research or not enough research to synthesize. That's why the first step of a systematic review is prepare your topic. Take a quick look at the available evidence to make sure there's enough research to address your question. Then, craft a question that's clear and specific enough to help you decide what kind of studies should and shouldn't be included in your search. Once you've prepared your topic, you can go on to step 2, search for studies. Of course, you'll go to electronic databases to find published articles related to your question. But to find all of the evidence related to your questions, you might have to look in some unconventional places. Once you've searched everywhere for evidence, you can move on to step 3, screen your studies. In this step, you take a careful look at what you've gathered, removing evidence that doesn't answer your question or has research methods you want to avoid. Once you've sifted through all your evidence, it's time for step 4, extract the data. Take the evidence that's left and pull out the information that will help you answer your question. Once the data have been extracted, you will need to carefully combine and analyze what you found. This is step 5. Analyze and synthesize your evidence. If you're conducting meta-analysis, this is where you'll use statistical tools to combine your data. You'll also look at your studies to evaluate the quality of the research and check for bias. Once everything is prepared, you'll combine all of your evidence together to summarize the research that addresses your question. Now you're ready for the last step, report your findings. Once you've decided what the evidence has to say about your question, turn your conclusions into a report that describes the steps you took and what you discovered. Then share it with anyone who cares about your question. Want to answer more questions with a systematic review? Don't forget the steps. Prepare your topic, search for studies, screen studies, extract data, analyze and synthesize evidence, and report your findings. There you have it, the steps of a systematic review. Enjoy!
Pros in health scientists, including dentistry systematic reviews and meta-analysis. Outside one that other study design do, the inherent high level of evidence to assess the correlation between the structured variables listed in data extraction section above and the overlay. Citation count from Web of Scientists of Google Scholar. Direct numbers of reviews include in the assessment which prevent additional analysis and affect the external validity of the result. The methodological quality does not necessarily indicate the quality of evidence of encompass.
What are systematic reviews? Systematic reviews help make sense of many kinds of data. They're a way of reviewing all the data and results from research about a particular question in a standardized, systematic way. A systematic review helps give an objective and transparent overview of all evidence surrounding a particular question. The Cochrane Collaboration logo visually represents how results from some systematic reviews can be explained. Here's how a systematic review works. First, a question must be defined, and an objective method for asking the question is agreed. Imagine a circle as the area defined by a question. Everything inside it concerns the question. Everything outside of it does not. In this circle, relevant data will be included. A search for relevant data begins. This data can come from many sources, including data from clinical trials. Imagine the shapes represent data sets from different research, for example, different clinical trials. The data set must be the right shape to fit. Only data from research that matches certain criteria can be included so that the results are reliable. For example, selecting research that is good quality and answers the defined question. If the research meets the criteria, more detailed information about the research can be collected or extracted. Information extracted can include how the research was done, often called the method, who participated in the research, including how many people, how it was paid for example, funding sources, what happened, the outcomes. This information is judged against criteria in order to assess the quality of the research. Once the information is extracted, it can be combined using complex statistical methods to give an overall result from all of the data. This circle is one way of representing this data visually. It's called a blobogram or a forest plot. The area of inquiry, defined by the question, can be divided into a yes and a no half, a positive and a negative side. The shorter the line, the more confident we are of what the data is telling us. Think of a longer line as less focused and scattered data, and shorter as more focused and bunched. Imagine knowledge as light and ignorance as darkness. The more spread the focus of the light, the weaker it is, and the less clear things are. If the light is focused and data is gripped more clearly, we can be more confident of what we see. The diamond represents the combined results of all the data included. Because this combined result uses data from more sources than just one data set, it's considered more reliable and better evidence. The more data there is, the more confident we can be.
Applied in Ecuador. It is important to know that the number of times of published article is cited. It is not indicate of its scientific values, but shows its influence on the progress of the respective fields of research and applies in any country, including Ecuador. However, an article related to implantology may have more citations. This biometric analysis provides insight into the progress and the interesting trend of dental implant research. Over the last 30 years, obviously, this is a dynamic list that is changing over time, according to scientific interest and prevalent research tendency that has evolved over the decades. Thank you.